Okay, we are live. Joining me today, a very special guest. Graham, can you please tell us a little bit about yourself for those who may not know who you are?
Hi, Rich. Well, thanks for having me on the program. Okay, I'm a philosopher. I've been around doing philosophy for quite a long time. I grew up in the UK where I did my education. Then the first place that offered me a full-time job was Australia. So I moved to Australia and I've lived most of my adult life in Australia. I worked at a few universities in Australia and then a university in the US, the City University, offered me a job in New York, and so I moved here, and I've been here for about just over a dozen years now.
Okay, yeah, so what year did you come to New York? That was
That's
2000.
how you count. I think I first started here in 2009,
Oh,
although
okay.
for 3 years I was half and half. So I was half the year in New York, half the year in Melbourne, and the other half of the year in Scotland in St Andrews.
Okay, that's a lot
But
of halves.
I've been here full time since about 2013.
Okay, I see. Yeah, because I finished up at the grad center around 2008, and I'd never had a class or anything with you, so I was just curious about the timing, just for personal
Hmm.
reasons. But yeah, interesting.
Yeah,
Okay.
well, you got out before you had you had the good fortune to get out before I arrived.
I don't know. I don't know about that. Of course, I had a spy on the inside, one Alex Kiefer, who you may know.
Oh, yeah.
So I was getting the inside tip about how cool your work was. And I have a kind of want to start off by asking you a kind of general question, which I've heard you answer before and in your work you've addressed, but I want to kind of start off by getting your take on the relationship between logic and reasoning, just generally speaking. Because a lot of the things I kind of want to pick your brain about and push you on a little bit is this relationship. And so I just want to kind of see where you stand on it. Because oftentimes you'll start off by saying logic is about what follows from what. And so, yes, that's interesting. But is that supposed to be like a theory of reasoning or is it something? Anyway, so I'm just curious.
Yeah. Well, look, um, both words get thrown around in very different ways,
Mm-hmm.
and to a certain extent, it's just how you choose to use the terminology. But reasoning, roughly speaking, is the fact when we try to figure things out. Um, and that might involve coming up with new ideas, testing them, drawing consequences from them. Uh, so it's kind of generally problem solving
Mm-hmm.
and looking for reasons and things like that. That's very vague.
Yeah.
But logic, again, is used but in different ways by different thinkers. Um, Modern logicians tend to use it in a very specific way, namely as a subject which discusses what follows from what and why.
Mm-hmm.
So when part of what reasoning is when we have certain things we believe or we're considering, and we figure out what the consequences are.
Mm-hmm.
And maybe if we believe the things in question, the premises, we'll believe the conclusions, what follows from them. And maybe if you think the conclusions are absurd, well, you'll think that the premises should be rejected in the first place. So that's a fairly precise notion of logic. As I say, not all thinkers in the history of philosophy have used it in that way, but that tends to be the way that modern logicians use the term,
Mm-hmm.
which is not to downplay all the other things that go on in our cogitations, like thinking up new ideas, new theories. But logic in the very precise sense that I've defined it is only part of that.
It's part of that. But so you're not thinking of it as like a. Sometimes you hear people talk as though like formal logic is to reasoning as the mathematics of quantum field theory is to the physical world in a certain way. That one's a kind of abstraction or a reified piece of a segment of or something that's been formalized, but that what we're trying to model or capture is that thing that's out there. And so it sounds like that's not the way you're thinking about this relationship.
Not really, no. And I think it's worth saying that um, reasoning is a normative matter. People reason, and they reason badly a lot of the time. We know that from studies in cognitive science. So we'll give that study to the cognitive psychologists. And when people study reasoning and logicians study reasoning, they're interested in how you ought to reason,
Right.
the norms of good reasoning, as it were.
Exactly. And that's why I'm interested in this question because, for example, for someone like me, and obviously for you, who's friendly to a kind of paranconsistic logic, and you've obviously done all the work developing it for us to be friendly in this way, but I'm very friendly to like the LP kind of outlook and all those sorts of things. So when you're thinking about these kinds of things, and in particular, when you're kind of looking at classical logic, and you're looking at argument patterns like explosion, and you're thinking to yourself, kind of naively, doesn't it seem like that argument pattern should be invalid? And then kind of one powerful argument for a kind of, dialethism or paraconsistent view in my mind has always been, well, you can show how it's invalid if you take this other logical system seriously, and then it validates our intuitive notions about which things are valid. In this case, at least, maybe in some other cases it fails. But in this case, we get validated and we get to say, yes, explosion is an invalid inference. And so in that case, when we're kind of thinking in this way, I would tend to want to say that our formal theory is kind of trying to capture our intuitive sense about what's valid and what's not, which is, in other words, what we think of as ordinary reasoning. What do you make of that way of thinking of things?
Yeah. Well, look, what's good reasoning and what is not obvious. Okay. And people have been constructing theories of this since there have been people interested in logic. And that's true in Western philosophy and Eastern philosophy. But just to focus on Western philosophy in a minute, there have been many theories about what constitutes good logic in the last 2,500 years. I mean, right at the start of the subject, Aristotle disagreed with the Stoics. And although there have been sort of periods in time when there was general agreement about what constitutes good logic, that's often broken down, and we've often changed our views. So the views that we hold now are very different from anything that was held before, say, the end of the 19th century.
Right.
So this word classical logic is a sort of misnomer because it's actually an invention of the late 19th century associated with the names of Frege and Russell and people who've polished it up since then.
Right.
But what we're doing when we theorize is trying to find the account of the correct norms of reasoning. Okay, so when you theorize, you're theorizing about something, you have a phenomenon you're trying to justify or produce a correct theory of. And of course, that means you have to check it against data, because any theory is trying to explain something,
Right.
and that provides the data against which you check your theory. So if we do have patterns of reasoning that we find cogent, that's going to provide a bit of the data you use. And conversely, if you have patterns of reasoning which don't look cogent, then that'll be another bit of data. But the trouble is, in any theoretical inquiry, the data is fallible. And we can start off with data we think is right, but turns out to be wrong. So a good theory, or a theory which is good for other reasons, I mean, strong by the usual canons of theory choice, might actually tell you that something you took to be valid ain't. And that happens often enough in logical theorization.
Where there's a certain pattern of reasoning that someone has taken for granted as valid, and then someone discovers that there's a flaw in it, or you can provide a counterexample.
Well, you come up with a different theory. So, for example, Aristotle thought
like the syllogism versus the quantified logic stuff.
Yeah, that's okay. Or even much simpler things. Aristotle thought that all men are mortal implies that there are some men. We don't normally think that's valid inference now.
I don't want to get too bogged down because there's a million things I want to ask you about, but just on two things. One about whether classical logic is a misnomer. I agree with what you're saying because classical usually means coming from the ancient Greek world. But I wonder if, like, part of the reason why it's an apt misnomer in a sense, if you would agree that it is, I wonder. But if you would agree, I would say it is because the thing that's coming from the classical world is the law of non-contradiction, which Aristotle does argue for. It is in the Analytics. He does try to make, or in metaphysics actually, isn't it? I don't know. I'm not an Aristotle scholar. Somewhere in there, he tries to make a case for it. Maybe it's not great, as I think you know, but he tries to argue for it, and that's the thing which gets preserved in the kind of Frege Russell tradition, which is why they call it classical logic. Is that fair? Do you think?
Well, okay. You Aristotle defends the law in the metaphysics, not the analytic.
Right.
The
Okay.
analytics, where he does his logic, where you find syllogistic, is the prior analytics, not the
Right.
metaphysics.
Yeah, I forgot. That's what made because I just made me realize that I want to ask you about logic as a theory of reality as opposed to reason as well. And I think that's sort of way maybe where Aristotle's at.
Okay. Now, it's true, nonetheless, that Aristotle defends the law of non-contradiction, right?
Okay.
And that the law of non-contradiction is endorsed in classical logic. That is the logic that you was invented by Frege and Russell at the end of the 20th century. But of course, there are lots of non-classical logics, things we've invented or people have invented since the invention of classical logic. And explosion, or let's stick to excluding non-contradiction. Non-contradiction is valid in those as well. So non-contradiction is not distinctive of classical logic because there are lots of logics that endorse it, like
Like
intuitionistic logic.
intuition. But so this is something that's always confused me. Maybe now I'm figuring out why it's always confused me, because I've always thought that the law of excluded middle and the non-contradiction are logically equivalent. But of course, that would only be in classical logic where they're equivalent. So maybe in intuitionistic logic they aren't equivalent, which is why one holds and the other doesn't. Which is what you're saying, basically.
Yeah, look, there are issues here about how you actually formulate these things, but let's slide over that for the
Okay.
moment.
Yeah.
They're not equivalent. There are plenty of logics where one can hold and not the other, as we now know. And in fact, the first person to reject the law of excluded middle, oddly enough, was Aristotle,
Yeah.
because he defended it in the Metaphysics. But then in this rather strange chapter of De Interpretatione,
Right.
he actually talks about things about the future being neither true nor false. So the history is much more nuanced about these things than we
Yeah.
have to pretend.
And that's the other kind of thing I was going to just mention really quickly off the cusp was the idea that Aristotle thinks that all men are mortal implies that some men are mortal. As far as I understand, the actual Aristotelian idea here is that he only thinks that if you kind of know that there are men, that if we put it in it, that the domain of quantification is not empty, but if you have a chimerical term, then that inference isn't valid in Aristotle's own system, or at least that's what I was told by certain persons who want to defend Aristotle. So I don't know if that's accurate or not because I'm not a scholar on this issue. So I wonder what you might say to that.
Yeah, look, I'm not an Aristotle scholar either, but the canonical text is where he describes the square of opposition. And he does say that all A's are B's implies some A's are B's.
Right.
And there's nothing in that text that I remember about restricting the A's and B's.
Okay. Yeah. All right. So then in that case, there's just a straightforward disagreement about which things are valid. And okay. So and this is going to be another kind of
Well,
question.
that's just one example of
Right.
differences, because there are syllogisms which Aristotle says are valid, which we would now not think as valid. So things that the medievals called derapti, for example, is like that.
Right.
And oddly enough, Aristotle's logic is syllogistic. Sorry, Aristotle's logic is syllogistic, but he tells us that contradictions don't imply everything.
Right.
So syllogistic is actually, oddly as it may seem now to people, a paraconsistent logic.
Yeah, that is interesting. He doesn't. Does he anywhere go through and actually try to? He doesn't work that out in the way he does in the prior analytics with all the other
Oh, yes, he
forms.
does. He points it out in the prior
Oh, he
analytics.
does. Okay, I
Oh,
did
he
not know
does, yeah.
that.
He says explicitly contradictions imply some things in some moods, but in other moods they don't imply anything. And he gives a few examples.
Interesting. Okay, so the history is much more nuanced, and then a lot of people, and I think that's an important lesson because people do tend to bandy about this simplified version of history, as though these things were always set in stone, and it's always been a little bit more complicated than people take.
Yeah.
And I think that's an important point to make. But I have two kind of questions I want to get your response to, and these are things that maybe you could think of them as kind of objections to the way the anti-exceptionalism, which I kind of hear is what is in the background of some of the things that we're talking about. Although I don't like that word either. I think you don't. I'm agree it's a strange word. But anyway, there's kind of two mainstream objections. One coming from a Timothy Williamson type, and then the other one coming from a Kripke type. So the Timothy Williamson type is going to say, look, you can have all this stuff in the formal language, but you're always going to get the law of the non-contradiction or whatever it is that you are trying to get rid of at the meta level. So maybe your formal system will have it, but at the level of reasoning, at the level of us using the system, you're always going to have a system that excludes these contradictions and so forth and so on. So of course, there's a lot of details in Tim's theory, but I think that's the kind of gist of it. So I wonder what your response to that kind of criticism is.
Yeah. Well, look, Tim and I disagree about these things. So I'm sure he'll object to anything I say. However, non-classical meta theories are known. For example, we know what intuitionist to meta theory of intuitionistic logic is like. So it's not the case that in meta theory you are forced to use classical logic. Tim would probably point out that meta theory is often done using classical logic, and he's probably right about that. But that certainly doesn't show that it must be done like that. And we know that there are ways in which you can recapture classical reasoning in a non-classical context. So even if we do use classical reasoning, that doesn't actually show that classical reasoning is right. We know, for example, that you can use intuition. So even if you're an intuitionist and you think that intuitionistic logic is correct, they will tell you, intuitionist logicians, that you can use classical logic in certain contexts, namely that those are decidable.
Right.
So it's generally agreed that you can, even if you're a non-classical logician, you can use classical logic in certain contexts. So if we do use it in a meta-theoretic context, that doesn't settle matters at all.
Right. Yeah. I think that I would want to, the way I would want to phrase it, which is probably not the way he would want to phrase things, but the way I would want to pursue this line is to focus just on naive reasoning, sort of pre-theoretical reasoning, with this thing we were talking about before that we're kind of, the data that we're trying to capture or something like that. And it sort of seems like at that level is where you would expect these classical laws to pop back up. When you're thinking about the formal systems themselves, it seems like you're always reasoning in a kind of consistent way. I mean, you're never not using the rules and not using them or something like that. So it just seems like at that level where you're thinking about the system itself. So even when you're doing truth tables for LP, for example, like every line, you know what to write there and you know how to think about it, even though you're writing that it has both values or whatever, and you know how to reason through it. So at the level of common sense reasoning, it just feels kind of like you're reasoning classically about a non-classical system. That's kind of what I take as the heart of what Tim's trying to get at. but maybe I'm wrong. But anyway, that's what I think. So I wonder what you think about it.
Yeah, look, we reason naively all the time. If you train in law or you train in mathematics, you learn how to reason. And of course, that's been the case with law and mathematics for several hundred, if not thousands of years. And people aren't taught formal logic, they're just taught to reason.
Right.
And then there's the question of how you theorize the good reasoning they do. So this takes us back to the question of constructing a theory which best explains the correct norms of reasoning. And that's going to raise all the kinds of issues we were talking about.
Exactly. So, and that's why I think all these things are related. And then, so just to tie this all together, then from the Kripke side of things, I'm thinking of the adoption problem and the idea that you're kind of saying that you could kind of reason your way to thinking that non-classical systems were the best form of logic and adopting them in a sense, in the Kripkean way of coming to choose to reason according to the rules of that system, I think. So first of all, do you think that this adoption is the way? So if for someone who liked non-classical system, should they adopt a pair-consistent logic and then reason in that way? I'm guessing you're going to say yes, in the right circumstances, that
Sure.
would be relevant.
Yeah, look, Saul's adoption problem is much more specific than most people tend to think. What he shows is that there are certain principles of inference such that you cannot persuade someone by using them. Okay, let me rephrase that. If someone doesn't believe one of these principles, then there's no hope of reasoning them into adopting them, because the reasoning, at least most natural reasoning, would require the very form of thing that's in question, right? That's what it shows. But for a start, that only applies to some principles of inference. For a start, that says nothing about getting rid of the principles of inference. It's about adopting them. And moreover, as a number of people have pointed out, there may be ways of rationally persuading people that you should have these principles without doing the kind of flat-footed sort of argument that Saul's thinking of, which is the natural argument, but there are others.
Right. So I wonder how, because I mean, as far as I understand it, there's at least two principles that he thinks this applies to. So there's universal instantiation and then modus ponens, maybe. And maybe you
Those are the
combine.
usual examples.
Say again?
Yeah, those are the usual examples.
Yeah, exactly. And then maybe you can combine them into some kind of quantified, modus ponens or something like that. So great. And what I'm hearing you kind of say is that doesn't apply straightforwardly to the question of whether I should adopt classical or non-classical logics, because it only applies to those inference rules, is what you're saying.
No, I mean, those
Okay.
two rules of inference are endorsed in most formal logics, but not all of them. So, I mean, if we are just restricted to those two principles, then there's nothing specifically about classical logic that tells you. Because, I mean, both of those are valid in most paraconsistent logics, for example.
Right. It's just that modus ponens is usually logically equivalent to disjunctive syllogism, and in
Correct.
these systems it's not. So you have to block that.
Well, usually, okay. I mean, if you think that the conditional is the material conditional,
Right. I see.
which was orthodox between about sort of 1910 and 1970. I don't think it's been orthodox. Well, look, first of all,
Some of us are Griceans out here,
yeah, fine. Look, but first of all, at least since the 1970s, it's been common to distinguish between indicative conditionals and subjunctive conditionals.
Yeah.
And no one thinks that subjunctive conditions are material, right? It's more contentious whether indicative conditions are material, but the orthodoxy that they were, I think, is fragmenting and disappearing just because of attacks on that by relevant logicians, intuitionist logicians. And the problems with the material conditional are not just the old stuff about paradox and material implication. There are lots of problems which have been pointed out, in fact, by people since the 1960s and 1970s, which have virtually nothing to do with the paradox of the material conditional.
Right. Exactly. Okay. So, and this is, I mean, the conditionals are hopeless. I don't think there's any widely accepted generalized theory about the conditionals, indicative conditionals that's successful. Um, People have their pets though that they like to talk about,
Of course.
but I guess what I was so the issue so what I was questioning was whether you thought Saul's argument was only aimed at or successful towards these rules of inference, because I interpreted his argument being you can't adopt a logic because in order to adopt it, you have to reason about it. And so that requires some pre theoretical notion of reason, which allows you to work with the formal system. But so this kind of suggests the very idea of adopting a logic as your reasoning system is incorrect or misguided. So that I thought the argument had a much wider implication than it seems that you're suggesting.
Look, I think so. I don't think Saul was always very careful
Yeah.
when he gave arguments. Um, and I don't think he makes that kind of claim. Maybe people have read that into it, but I don't think that's true. Um, what's certainly true is that we reason naively, and presumably our reasoning is systematic in some sense. We might um, have different theories of what the correct reasoning is, but let's suppose we fixed on one. There might be reasons why we come to change our mind. So one reason we might come to change our mind is that our theory just gives the completely wrong results. And then we have to figure out a new theory. Some reasoning will be involved in that process probably, but nothing sacrosanct.
Right.
We're trying to find the best theory that works overall. And as Quine emphasized some time ago, not that I often agree with Quine, but anything is up for grabs
Yeah.
if you find something that works properly, which in other words is the best theory of how you should reason.
Interesting. Okay. All right. So I want to follow up on that, but I want to lose kind of the track of the kind of big picture I was trying to get at here, which is, first of all, what is logic? Is it a theory of reasoning or is it a theory of reality? Because I think that oftentimes when people go and talk to non-philosophers and we're thinking about this stuff, we're thinking in terms of reasoning, or at least, what follows from what in this way we've been discussing. But I think kind of naively, a lot of other people are thinking that logic is somehow built into reality, and that that our formal systems are trying to capture that. So I wonder what and this was in my opinion, this is like an old school way of thinking of logic that maybe traces back to the way back whens, and isn't the way we think about it in the contemporary world. But I wonder, like, what is your take on this relation about reality itself and logic?
Look, there have certainly been many people who thought that there's a very close connection between reality and reasoning, okay, from Ibn Sina to Wittgenstein in the Tractatus. Um, I think there's an element of truth in this, although not in the kind of flat-footed way that those two guys thought.
Okay.
But when one reasons with deploying certain categories, such as um, predication, quantification, and so on.
Right.
And how those categories work are going to constrain any theory of reality that one constructs. So there is a dependence of one's metaphysics, as it were, or one's logic. So, no, just to come back to Aristotle, for example, if you, in De Interpretatione, he gives a theory about the open future. So he says that, okay, scholars dispute exactly how you understand it, but the most natural way of understanding it is that statements, or at least contingent statements about the future, now have no truth value. They're neither true nor false, although they will be true or false in due course.
Right.
Now, that assumes that truth and falsity and negation, maybe disjunction, work in a certain way. If you subscribe to the principle of excluded middle, as he appears to in the metaphysics, or if you subscribe to classical logic, then that theory about the future is a non-starter.
Right.
Now, I'm not telling you the theory is right, but I'm just giving you an illustration of how how the logical categories work, constrain or can constrain your theories about the nature of reality.
Right. Yeah, exactly. So, and that's why I thought, maybe sometimes people will read Aristotle as saying, what I want to do is give a formal theory for a part of language, like maybe present tense indicatives and not future tense indicatives, which maybe that's not that they're neither true nor false, which is what he says, but they just can't be fit into this theory that we have. So they can't be assigned a truth value because it only assigns truth values to present tense indicatives. Maybe that's reading too much back into the old days, but I mean, I does get the feeling that this is kind of an approach that one can have, that we don't need a full theory of everything, but we're trying to do a fragment of a part of language.
Sure. And I mean, any logician who's thought about these things for a while will know that it's very hard to fit everything we do into any Procrustean box.
Right.
So we do idealize, we do make simplifying assumptions, we look at special cases. Often we don't sort of make that clear, but we do. So something like that may well be true. Was Aristotle doing that with his syllogistic and his excluded middle and long contradiction? Look, I'm not an Aristotle scholar, but I don't think so.
Exactly. Okay. And the reason why I'm asking about this is because obviously you are a dialethist. I think you believe that there are true contradictions, that they exist, not that that they really exist. I don't know how else to say that, but that metaphysically, in reality, there are contradictions, not just informal systems.
Let's be careful.
Yeah. Okay.
Dialechism is the view that some contradictions are true. Okay, it says nothing about what truth means.
Right.
Explicitly, you can have, I've pointed out, you can have any theory of truth.
Right. You could be a Horwich and still like dialechism.
Yeah, you can be a deflationist.
Yeah.
You can be an idealist. You can be a pragmatist. And I'm quite happy to give the correct theory of truth to anyone who wants to have a stake in that race. I mean, I've never endorsed that, okay? I've never endorsed any particular, well, that's not quite true. The only theory of truth I've ever endorsed was a theory that I called the teleological theory of truth, which no one else has ever believed. So we leave that aside for the moment. I've never endorsed a realist theory of truth.
So you don't depend on a correspondence theory of truth, is what you're saying?
No, no, which is kind of the absolute minimum you need to get anything about from some things are true to there are truths in the structure of reality, or however you want to phrase that. And it's not at all clear how you should phrase that.
Right, exactly.
But, dialechism as such is not committed to the thought that there are truths in reality. I mean, it's not even clear that that claim makes sense. If reality is composed of stars and chairs and people, to say they're true or false is just a category mistake.
Right.
Only propositional like things, or maybe states of affairs or facts or something, can be true or false.
Exactly. So I think this is an important point, because a lot of times people portray dialethism, not people in the debate that you're used to having, but I think outside that who are looking in, they think, oh, dialethism is the claim that there's like somewhere like a literal contradiction that you could stub your toe on in the same way that there's a tree or a rock or something like that. And what you're saying is that's an added on feature. If you believe that, that's something in addition to the claim that there are true contradictions, because you've added in a theory of truth and metaphysics and a whole bunch of other stuff that this theory is silent on.
That's exactly what I'm saying.
Yeah.
And if people attribute the view to me that there are contradictions in that sense, well, then they just haven't read what I've written.
Right. Okay. Yeah, good. So now, so do you deny that there are contradictions in that sense? Or would you say that you're suspicious of it, or do you not want to even commit anyway?
Well, let's get the sense clear first of all.
Okay.
What do you mean?
So what I mean is like mind independent reality, that there is a feature of the world which could be correctly described with a contradictory proposition, or
Sure.
which
No,
exhibits contradictory properties or something like
yeah,
that.
I believe that.
Yeah. Okay. Good.
I mean, just take a statement. I mean, contradictions are things which are expressed in language. So we're dealing about statements, talking about their truth or falsity. And generally speaking, it takes two things to make a statement true. Okay. So take the sentence, Canberra is the federal capital of Australia, which is true.
Okay.
What makes it true? Well, two things. First of all, the meanings of capital, Australia, federal.
Right.
Okay. So it's partly to do with the meanings of words. But of course, that's not sufficient, because it wouldn't be true unless there were, some historical and geographical facts about a country in the southern hemisphere of our world. Okay. Which is about reality in, non-linguistic reality in some sense.
Right.
So you need those two things to cooperate. So, I mean, anything that's true, apart from maybe analytic truths, are true in virtue of something that happens in non-linguistic reality.
Right.
And dialectics are no different.
Okay.
So I do think that in some things which are clearly about non-linguistic reality, meaning and the world can conspire to make them true. I mean, I do think that motion, for example, is a contradictory phenomenon. And motion is certainly a part of the world.
So now this is relating to the Zeno paradoxes, which is great that you brought that up, because I wanted to ask you about this. But before I sort of ask about the specific Zeno stuff, can I ask you that would motion be contradictory apart from humans doing anything? So, for example, if there were an alternative universe where there were no humans but everything was identical, would motion be contradictory in such a case?
Yeah, if things move.
Yes, good. Okay. So it's not just that language and reality conspire, it's that there's something actually extra linguistic that's out there that is contradictory in a sense, some
Yeah,
sense.
it's moving things.
Yes.
Okay. But the language in which we describe motion is, of course, ours.
Yes.
We don't have to we can use our language to describe other worlds, and that's not a problem. So the statements we make about what's going on in that world involve our language, but they involve the goings on in those worlds.
Exactly. Okay. So, and I just wanted to be clear that you weren't saying it's something about the language conventions or something that can conflict with the world or like tie us up in a knot or some Wittgensteinian thing. But so I think I think I have it. So now with respect to Zeno, I'm aware of the paradoxes. I think, the paradox of the arrow and the infinite divisibility are the ones that get the most attention and the most likely to be valid. The other one's not so great. Maybe I'm wrong, but that's how I feel. So can you tell, what is wrong with the standard kind of reply to Zeno that involves a lot of calculus?
Yeah. Look, you need to distinguish between the ones that involve infinite division, like the Achilles and the tortoise, for example,
Okay.
and the arrow. The arrow is a bit different from all the others. And I think the standard reply about sort of how we think of adding infinite sums and things is perfectly correct. Okay. It's the arrow, I think, that isn't really treated in that way. because it doesn't require this kind of thing.
Oh, okay. So you're
Just
perfectly fine with the idea that once you get rid of infinitesimals and have the concept of a limit, then there's no kind of problem. Cantor and all that stuff gets rid of the problem for the divisibility one.
for the divisibility ones, I think the orthodox solution is perfectly right.
Okay.
Okay.
I didn't know that. Interesting.
It's the arrow.
So it's instantaneous velocity. That's the thing you're objecting to?
Correct.
Okay.
Correct. So, I mean, if you look at the arrow in its flight at one instant of motion, then it makes zero progress on its journey. And the whole journey is composed of instants. That's orthodox mathematics. And it would appear that the progress made in the sum of instants is the sum of the progress made in the instants. And a sum of zeros, even transfinitely many, is zero. So that's the argument. It shows that the arrow can't advance on its journey.
Okay.
Now, the stuff about limits is not relevant to this at
Yeah.
all.
I see how that's not relevant. But there's stuff about instants that is relevant.
Sure. And one thing you might want to say is that continuum is not composed of instants, it's composed of intervals, right? Some people have suggested that, but of course that runs against standard scientific assumptions that a continuum of time or space actually has a structure of the real line, which, in modern mathematics is composed of points.
Right. So now this is an area where I'm really stepping in waters that will are over my head. But as far as I understand the kind of this history of the what is the continuum, which is extremely interesting. The how to construct a continuum out of discrete points has been a bone of contention for a long time.
Correct.
And it's kind of been done in many different ways, and so it's not clear like the history of that's very contentious. But I think the modern version of it, based in set theory, well, does the modern version of it, which is based in set theory, retain that same structure as these earlier versions?
Which earlier versions are you talking about?
Dedekind and the slices and all these things about how. So as far as I understand, Cantor's idea, he tries to construct something called a connected set, where you have so to say that a function is continuous at a certain point is to say you have some collection of points and they're connected in a way, namely that one is between the other or something, or the one's between the one that's between the other. Yeah. And then you can say there's so that's how I'm thinking that it's built up out of points. And what I'm asking is, does modern, ZMF and all these kind of modern set theory approaches, do they still take this idea that it's built up out of points?
Yes.
They do.
Yes.
But I thought it was built up out of the empty set.
Well, in set theory, everything is built up out of the empty set, but we're talking
not
about
points.
Yeah, well, yes, they are, because they're okay. So if you look at the standard account of set theory, you start with the empty set and you take the power set of that and the power set of that and the power set of that and at limits you collect up and then you keep going.
Right.
So everything is ultimately made from the empty set by operating with the power set and collecting up at limits, right?
Right.
But in that, you will find the real numbers. Okay. Now, as you pointed out, people were not sure what real numbers were. There were various problems, but there were at least 3 different constructions of the real numbers from the rational numbers in the 19th century. One was by Cantor, one was by Dedekind, and I think there might have been a third one by Weierstrass. And they're all perfectly legitimate constructions. They do what they're supposed to do. And
which is what, reconstruct the hierarchy of the natural numbers?
No. They explain why the real numbers are uh, okay. Let's step back. The real numbers uh, are constructed out of sets of the rationals. Now, the rationals are fractions, and the fractions are dense. Between any two fractions, you can find one between them.
Right.
So you just add them together and divide by two, right? But the rational numbers are not continuous. And people knew that the difference between the real numbers and the rational numbers was the real numbers are dense in the same way, but they don't have the gaps. So, I mean, well, they have gaps in the sense that if you can take a limit of rational numbers and it won't necessarily give you a rational number. So, for example, look at the decimal expansion of pi, which is something like 3.1416. Okay. You can think of that as a limit of rational numbers,
Right.
3.1, 3.14, 3.147, 3.1472, and so on. And that's a perfectly good limit, okay, but that the limit is not rational. That's a very old result. So there's a question that the rationals seem to have gaps in. And the thing about the reals is that it hasn't got any gaps. If you take any sequence of reals that converge in that way, you're going to get another one.
So is what you're saying that if you think of the number line and you put the natural numbers 1, 2, 3, 4, then you can also add these other numbers like pi and e and so forth. And so then you'll see that there are gaps in between those numbers. Like there's a gap between 3 and 4, and in that gap there's pi. And then
Yeah,
there's like, so it's
not,
like there's a discrete thing there.
it's not just the rationals. I'm talking about the fractions.
Oh, I see. Okay.
Okay. So between any two fractions, let's take a half and 3/4. Well, there's a fraction in the middle of those, which is, what is it, 5/4 or something like that. You can work it out.
Okay.
And what sort of manifests this incompleteness of the rationals is that you can take a limit of rationals, which get sort of closer and closer and closer, and they don't have a limit point. There's nothing they converge to.
Right.
So they're not closed under limits, but the real numbers are closed under limits.
I see.
So the canonical constructions of the real numbers allow you to take, you want something that contains the rational numbers, but is sort of complete. In other words, whenever you get a convergent series of them, it always hits a target, as it were. The limit actually exists in that domain. That's what these constructions of the reals do. Okay, and there are several constructions. Any of them can be implemented into Milo-Frankel set theory. Mathematicians don't really care which you use, and frankly, neither do set theorists, because they know it can be done and they don't really care how it's done. Any way that works is good enough.
Okay. Yeah, and so they're very practically minded in that way. But what does this tell us about the continuum?
Well, the continuum. I mean, set theorists will call the real numbers the continuum.
Okay.
But if we're talking about space and time, we're not talking exactly about real numbers. We're talking about chunks of physical reality. So if you take a physical continuum, such as space or time, then we need to look to physics to tell us what the structure is. And standard physics assumes that you can use the real numbers to tell you something about the structure of space and time. So it's assumed that the structure of time is the same as the structure of the real numbers.
Right.
That's standard physics.
But up until the Planck length, at least, or do you think that? I mean, so is this going to throw in some kind of wrench here?
Look, I'm not a quantum physicist, but my understanding is that space and time had not yet been quantized. So even quantum mechanics uses the real numbers as the structure of space and time.
Okay. Interesting. Okay, so I know I'm getting distracted, but I want to get back to motion because that's the thing that was supposed to be our example of a manifest contradiction. And, I think it's very interesting. So, people say motion can't be contradictory. It doesn't look that way. And I think the right response is, how do you know what a contradiction looks like?
Yeah, that's
So,
exactly right.
so I mean, we could have been looking at one this whole time. And this is why I kind of wanted to ask about at the beginning your background assumptions about reality and reasoning, because when we brought out an example of a contradiction, I wanted to be able to ask you if you thought that it was something that was in reality or merely in the way we think about reality. Or whether we think about it because it is that way, or whether we want a theory of logic that captured the way things are out there or in here or both. So that if we start off with the idea that what's out there is something contradictory, then we want to model it in a way that makes sense of that. If we start off with something, the assumption that the world is not contradictory, then we want something that models it in that way. So a lot of this seems to me to depend on the kind of world you're in. And if you're in a consistent world, then you want one kind of logic. And if you're in a non-consistent world, you want a different kind of logic. So it's going to come down to what kind of world are we in, which is why I think Zeno's and these kind of arguments are so important. So first of all, before going any further, does that sound right to you, or would you disagree with any of that?
No, I think if you put it in those terms, I'd more or less agree with that.
Okay, good. All right. So then the
But
specific.
you're right. I mean, we want to know about the world in which we live, and to know that, we construct theories, and we try to figure out what the best theory is. And often, our theories will tell us that the world is actually not as we naively imagine it to be.
Right.
That tabletops are largely empty space, and they're composed of things which aren't coloured, and so on, which is kind of strange, but that's what our theories tell us. So we don't know exactly what we're looking at a lot of the time
Right.
because the world is not as it appears. So you see things moving, fine. Uh, does it appear consistent? Well, its inconsistency doesn't kind of strike you in the face, as it were, but often the world is not what strikes us in the face.
Right.
That tabletops are largely empty, for example.
Yeah, exactly.
So we look at our best theory to tell us these things.
And this is what I think is what's interesting about the ancient Greek philosophical. The way I like to frame a lot of those debates is it's one of the first times we really come face to face with this question about when do our formal systems accurately map onto the external world and when do they not. And the questions about motion and the continuum, I think, really are right there at the beginning because they're thinking in terms of the line, and is that a good model of distance? And triangles, is that a good model of that arch over there, that doorway,
Yeah.
whatever?
So what physical reality
Yeah,
is our best bet is told to us by our physics.
right.
Um, and nowadays our mathematics heavily informs our physics. And as we've talked about, one's logic can inform the categories we use in reasoning, which certainly involved in mathematics. So those connections stack up.
Good. Okay. So now the specific debate about Zeno and it sounds like what you're saying is Zeno was right about this arrow paradox. And many people will want to say, well, look, we can ascribe a property to the instantaneous object, the property of being over there in the next instant. And that's a kind of, I mean, I'm laughing because it's hard to say that with a serious face, in my opinion, but people will say that with a serious face and say, look, at this instant, we're ascribing to this thing the property of instantaneous velocity being over there. And you're saying, I mean, I guess what I would hear someone like you say is that's just a label of the problem, but not a solution.
Uh, it could be. Look, the orthodox, that is the Russellian account of motion, is simply to be in one place at one time and at a different place very close to that. Okay.
Yeah.
There's some technical issues there, but pass those over. Um, that doesn't really address the problem because the problem was how does the arrow make its advance? You're still stuck with the problem that it advances at no instant yet in some sense, in a sum of instance, it does advance. Now, if there is a mathematical solution to this, it's not in calculus, it's in measure theory. And so you're talking about distances, and that's, measure. And the standard measure theory says that if you add enough sets with zero measure together, you can get non-zero measure. There got to be a lot of them, okay? An uncountable infinity.
Wait, but hold on. So this is different than transfinite zeros added together is still zero?
Correct.
Okay. So
Because we're not talking about the addition of numbers, we're talking about measures. So this is, roughly speaking, the lengths of sets, which is different from their cardinality.
Okay. So you could add things that have zero of that together and get an zero?
So if you take, you can have a bunch of sets which have zero measure, and you can take their union, and they'll have non-zero measure. But that's an axiom. Okay. Of course, calling it an axiom, it just says, well, it happens. It doesn't. It's not an explanation.
Is non-zero measure somehow like a set theoretic equivalent of an infinitesimal? Somehow a quantity that's above zero?
No, a
but
non-zero
then
measure can be, 3 or 4.5 or 6 or pi.
Okay. Okay. So what makes it zero then?
What gives a set a zero measure?
Yeah.
Well,
I'm
okay.
sorry if I don't understand this. I just don't. Yeah, I know, I'm not.
No, look, it's quite possible for sort of fairly complicated sets to have zero measure. But the easiest way to get your head around it is something like this. Take a point. How long, suppose I got a set containing just that point. How long is the point? Has no length.
Yeah, zero,
Well,
right?
that's what it means to have zero measure.
Okay.
Now let's take another point, which also has zero measure, and let's put those two together. Then how long is that collection? Well, that's still has zero measure.
Yeah.
Okay. And generally speaking, for any finite collection of points you put together, it's still gonna have no length. And then, okay, some infinite sets are going to have zero measure, but if you add enough of them, an uncountable number of points together, then you can get something which has a non-zero measure.
Okay. So this would be a good way to construct a line out of points then.
Yes, that's what it's meant for.
Yes.
So if you take all the points between, say, 0 and 1, all the real numbers between 0 and 1, and consider the set of all those, then that's going to have non-zero measure because it has length 1. Okay. As a fact of mathematics, that's all fine. But that doesn't tell you how the arrow moves.
Right.
How does it actually make progress physically when it doesn't make progress at any point? That's not a problem of mathematics. That's a problem of physics.
Exactly. Yeah, it's a good point because when you, if you think about it from the continuum point of view, there was kind of a traditional answer, which is it makes progress by traversing through every point and having like, and so, okay, that's kind of commonsensically, like you go through A, B, C, D, you step over from one to the next. But what we're basically saying here is that there's no way to do that because at each instantaneous moment, there's no time for you to make it to the next one, first of all, and no way for you to physically transition to the next position.
Well, how is progress possible at a sum of instance when it's not actually achieved in any one of them? So you mentioned Zeno earlier on. I mean, this wasn't. He just posed this as a problem. He didn't have any account of motion in mind.
Right.
Hegel certainly did, and so what Hegel says is that if you consider the arrow in motion at a point, it actually does make a little bit of progress in that instant.
Right.
So it's both where it is, and it's also gone a little bit further, so it's where it will be, which is not yet. So in the logic, he says almost exactly this. What is it to be in motion? Well, it's not to be here at a certain point of time and here at another point of time, but to be here and not here at one and the same instant of time. So he's a dialethist in the history of Western philosophy. In fact, I mean, if you ask him that, suppose you've got something occupying a point at an instant. It could be at rest or it could be in motion. What's the difference? Well, if it's in rest, it's in a consistent state. If it's in motion, it's in an inconsistent state. This was his account of motion.
Right.
No, it's certainly not the orthodox view. Something like the Russellian account is the orthodox view, I think, to the extent there is one. But this was Hegel's solution to the arrow paradox.
Right.
And as we've been talking about, I don't really find the Russellian account of motion actually even addresses the problem that we were worried about.
So would you endorse this the Husserl?
Hegel,
Yeah, sorry, Hegelian. That's easier to say. Thank you. Would you endorse that?
yes.
Okay. So you think that it's a correct account of any object's motion to say that it's here and also not here at a particular time. And
Yes.
and would you say that the mathematics of calculus that's sort of what instantaneous velocity is? It's saying like it's here now, but it's not here because it's there next or something. So how would you want to map that on in some way to that?
Yeah, look, these are interesting technical questions. I'm not suggesting that a mathematical theory of motion in terms of the calculus is wrong.
Okay.
I think this is an aspect of it that has to be tied up with what you want to, how you tie up the notion of instantaneous motion and the contradictory state at an instant. And there are different ways you can do that. I suggested one in an old book of mine, which I think is not bad.
Yeah.
But these things are not of much interest to physicists for whom, the ordinary calculus is sufficient for their purposes.
Right. Okay.
But philosophers like to tackle conceptual problems about reality that maybe don't kind of work their way up to the surface in physics.
We don't like to be proved wrong. We're changing that though, obviously. We're changing that. Okay, so this is very interesting because one traditional way of like reacting to all of this stuff is to say, look, the problem is the theory of instants or temporal slices or time slices or instantaneous moments or whatever you like. So maybe you don't like the specious present or maybe there's a problem with these other kinds of accounts, but some other account besides instance has to be offered. But what you're saying is no, we can just endorse this kind of dialethic thing. So I'm wondering, like, well, what would be the problem with some other approach to this that's non-instantaneous in a way?
Well, it depends on the approach, of course. But first of all, standard physics tells us that time is built of instants. Okay.
Relativity
So
physics does. I mean, quantum mechanics
no,
doesn't
no,
mention
no,
time
no,
really at
no.
all.
Newtonian physics does too.
Right. Okay. Right. Right.
Um, this has been orthodoxy in physics ever since the 17th century. So you can have a different theory of the structure of the constitution of time, but then you've got to do justice to the physics. Okay.
Right.
And some people have suggested that you can think of physics as composed of instants, then you've got to say some of intervals, then you've got to say something about instants. And various philosophers have attempted that. So Whitehead did, Russell did at one time, how you can talk about instants in terms of approximations by intervals and so on. I've never thought carefully about those theories, but they would seem to face a dilemma, namely, if they really do justice of telling you how instants work, then they face the same problem. Okay. And if they don't, then they seem to undercut the application of instants in physics.
Interesting.
Now, I'm not saying it can't be done. Philosophers are clever bastards, and we'll give them a challenge, tell them to construct a theory which does X, and they'll usually come up with some kind of theory.
Exactly. They could jangle something up for sure. Yeah.
Yeah.
Eventually.
I- I'm not saying it can't be done, but I don't, it's certainly not well known how it can be done
Right.
easily.
Right. Okay. So, and on this very same topic, some people, like I lean this way, might say that ultimately maybe a theory of physics isn't going to have instants because time itself is going to be kind of an emergent property. Now, how you make sense of that is hard, but some people have tried. Maybe space and time are emergent properties from some kind of non-spatial, non-temporal system that may look, like amplitude hedrons. I don't know. We're not going to get into all the technical stuff. Anyway, so there's things that people say from physics, and I would say that if you look at quantum mechanics, it certainly doesn't seem to care too much about time. It's not like in the same way it does in relativity theory. It doesn't really show up. So
Oh,
maybe
look, I beg to differ.
okay, in the
Uh,
sense of you have to update the evolution of the Heisen uncertainty. Excuse me, the equation.
yeah, so the equation of the temporal evolution of the wave function is based on, the standard theory of time. And that's before you get to the collapse of the wave packet. I mean, this is just what happens before you observe things.
Mm-hmm.
So it's true that sort of strange things happen about observation, time and energy. You can't pin them both down exactly. But nonetheless, the evolution of the wave function is based on classical theory of time.
Okay. Well, all right. So I don't know enough about that to. I'll have to think more about that. But just in this instant regarding the instant thing that we're talking about, um, I do think that there's less of an emphasis of assigning these properties at an instant and then saying that they cause or bring about the thing around in the next moment. And we do kind of get used to the idea that electrons, have a probability of being here or there kind of instantaneously. And there's a non-zero probability that the electron could be on the other side of the universe, like the next time you check on it. It's a small probability, but it's there in the math. And so we kind of get used to the idea that these things are not really, travel. I mean, I don't think anyone has a theory about how electrons travel from one position to the next in quantum mechanics. I think they just say, here's an equation that tells you you'll find it here sometimes and over there sometimes to this probability, and it always works out that way. So I do sort of think if you think of things that way, then the Zeno point maybe loses its force because physics seems to suggest maybe things aren't moving in that way or we don't need an explanation. Um, I don't know. I haven't thought too carefully about this, but I wonder, like, if you could, if someone made that line of argument, what would you be tempted to say?
Mm. Oh, that's an interesting suggestion. Um, I mean, quantum theory deals with microscopic microparticles, whereas motion, as we normally understand it, concerns macroparticles. So there is a question of how you understand the connection between these two things. Um, I'm not sure what physicists say about that kind of thing nowadays. Um, I think most physicists would apply quantum physics to quantum states or quantum particles. But when it comes to doing good old-fashioned dynamics, they'll use Newtonian dynamics or relativistic dynamics. Um, so there's a question of how you tie up the motion of a billiard ball, for example, with the quantum states of the atoms or quarks or whatever that compose it. I, I have no idea what physicists say about that.
Okay. And even so, even if you kind of were like convinced by what I was thinking, you might still say, even so, a non-classical theory of logic is the best description for the macroscopic property of motion that we observe.
You might. Look, the devil is going to be in the details.
Yeah, the devil's going to be exactly. Okay. All right. Interesting. So I'm aware that the universe is ever evolving towards heat death. So I don't want to miss my chance to talk about some other things with you. So
Okay.
even though there's
Okay, it won't happen this afternoon.
yeah, exactly. Okay,
Pretty safe.
good. But I do want to sort of transition to ask you. So I find the Zeno paradoxes very interesting, and I'm persuaded by this kind of argument. To be honest with you, I've always tried to defend Zeno in my lectures, and people will know this for a long time. So when I read this stuff, I was like, oh yeah, fine, I'm not the only one, so that's cool. And I do find that people tend to dismiss this stuff too quickly because there's an assumption that reality just looks classical. And so what I've been trying to hammer on and bring out in this discussion so far is that's kind of really question begging. And really what we want to do is start trying to understand these things. And as soon as you try to get formal about it, you end up with these kind of interesting questions that
Yeah,
maybe
that's true. I mean, how often things are not what they look like, whatever that is.
right.
I mean, what does something look like that's 99.999% empty space?
Right.
Well, it looks like this tabletop. You wouldn't have guessed it, would you?
You would have exactly. So now, because this leads me to the question I wanted to ask about. Well, I want to get the Sylvian's box, but by the way, which I read a long time ago, and I reread for this, and I have some questions about it. But it's a good story. People should read it. I had forgotten like how open the contradiction in that story was. I was expecting when I first read it, it'd be some clever entailment that you had to work out that was like, oh, this is inconsistent. But no, it's just like, bam, it's in the box. So that's a nice approach. And I wanted to talk about it. But I want to, before that, ask about Gödel. Laughingly, he said. And I want to ask whether you think that these things that we've been talking about ultimately show that human reasoning isn't consistent, or whether you think we know that. Because I've always taken the Gödel conclusion to kind of be that, either this is incomplete or we're inconsistent. That the human reasoning process is not itself a consistent thing. So would that fit with your picture? And is that what you think? I guess is what I'm asking.
Well,
I know that's a huge topic, so if you don't want to go all down the rabbit holes.
first of all, I want to insist on the difference between how people actually think and the norms of correct thinking or reasoning, if you like.
I see.
And we know very well that people reasoning consistently all the time. If you ever taught Philosophy 100, you'll know that your students do, right? So we're talking about this more sort of rarefied area of the norms of correct reasoning. And the Gödel stuff, um, I'm just trying to think how to talk about this in as non-technical way as possible. Look,
You can be technical. You can talk about the girl sentence and all. I mean, that's fine.
well, yeah, okay, but I want to do this without using heavy mathematics. Let's think about the liar paradox for a moment,
Okay.
right? Which many people will know what it is. I mean, it's a sentence that says this sentence ain't true. And if it's true, it ain't. And if it ain't, it is. So you have a paradox, right? Okay, that's a well-known paradox. Now, the Gödel proof of the fact that arithmetic of any expressive power is either inconsistent or incomplete uses a very similar construction. Now that we know many proofs of Gödel's theorem, and they don't all work like this, but Gödel's original proof considered a sentence which sort of said, when it's coded up in arithmetic, this very sentence is not provable.
Right.
So it's not this sentence is not true, it's this sentence is not provable, but it's actually in the same family. And the reasoning is a bit more complicated, but You reason in much the same way, and you come up with the thought that it's provable and not provable. Now, you have to make a few assumptions to do that. And if you consider a very standard system of arithmetic, like Peano arithmetic, one of those assumptions fails at quite a surprising place. So you avoid the contradiction in Peano arithmetic, but for reasons that we wouldn't have expected.
Which axiom of piano arithmetic is the one that does it?
It's not an axiom. It's something that you can't prove. It, you can prove that 0 has a property, 1 has a property, 2 has a property, 3 has a property, but you can't prove that everything has that property.
Uh-huh.
Okay?
So mathematical induction fails, or that
No,
the collection
no,
of the
no,
whole
no,
entire
no.
set has a property?
What would fail is something logicians call the omega rule.
Oh,
If
right.
you can prove it holds of 0 and 1 and 2 and 3 and 4, it holds of all of them. And that's not something that is true in Peano arithmetic. Although, of course, it is the case that if it's true of 0, true of 1, true of 2, it's true of all the numbers. You just can't prove the universal
I
statement.
get it now. Yeah, it's true but not provable in piano arithmetic, right?
Yeah. But
But how deep
that,
is that really, is what you're kind of saying?
well, look, there's a lot of questions here. One of them is you might think that what that shows is just the inadequacy of Peano arithmetic, because there's something that is kind of true and you can't prove. But if you kind of um, incorporate what seems to be missing, you go inconsistent. Look, I mean, there are lots of technical niceties here, which I'm sliding over.
Okay.
But if you add the axiom which says whatever is provable is true, or whatever you can prove is so, then you go inconsistent.
Then you get the contradiction, right?
And we now know that there are systems of arithmetic which are complete in the sense that everything that's either true, if anything that's true is provable. Anything that's false, that's provable too. So it's complete, but it's inconsistent. So what the Gödel argument, any proof of the Gödel argument really shows you is that any arithmetic of sufficient power, that's a technical notion, is either inconsistent or incomplete.
Right.
And of course, if you assume consistency as a kind of something that's not debatable, then it's incomplete.
Right.
That's the way the Gödel argument, the Gödel result is normally expressed. But we now know that there are arithmetics which are complete but inconsistent. That doesn't mean they're right, but it means that, there are other possibilities which are now on the table which need to be thought about.
So are you resisting the more general claim, which some people would take as an implication of the Gödel theorem, that there's something about human reasoning which can't be formalized because
No,
we can see that the Gödel sentence is true but not provable, and so therefore whatever formal system you might have thought was equivalent to human reasoning, there's going to be some equivalent Gödel sentence in that system which we could reason about and say that's true but not provable, and therefore no formal system could ever capture human reasoning.
yeah,
You're not endorsing that, are you?
not at all. That's the old Lucas Penrose argument,
Yes,
and it's just
exactly.
wrong
Yeah.
because these inconsistent arithmetics are formal systems. They're axiomatizable. Um, of course, when Lucas and Penrose, gave their sort of infamous arguments, they didn't think about that. They didn't know much about power consistency. But
Exactly. So that's what I'm trying to get at here, Graham. Though what I'm trying to get at is, do you think that a formal paraconsistent system, that there is such a formal paraconsistent system which accurately captures what is this pre-theoretical thing we call human reasoning?
well, again, this brings us back to the question of if you talk about human reasoning, are you talking about the people?
No, how you ought to reason. How you ought to reason.
Yes, I think that how people ought to reason is using a paraconsistent logic.
Okay,
And that opens up the possibility of using an inconsistent arithmetic.
I see.
And I think there are good reasons to think that that's actually the right way to think about numbers.
So one way you could take the Penrose a generalization argument is that humans are, our reasoning system is either complete or paraconsistent.
That will be a fairly blunt way of putting it, but that'll do for the moment.
Okay. Interesting. So now, when you think that that people ought to reason in a paraconsistent way, then they're gonna, often these jokes, I got these jokes already when I was telling people that we're having this conversation. They're like, "Oh, you're talking with Graham, but you're also not talking with Graham." It's like, ha ha ha. No, that's wrong. Because obviously you're not going around saying everything is contradictory. You're simply saying there are some cases where we have good reasons to think that contradictions can be true. Now, one thing that I've always wondered about this view is, of course, you might say you also have good reasons to think they're false, right? Because they're contradictions.
Yeah.
Right, okay. But you never really emphasize that aspect of it, that we have good reasons to think they're false as well.
Oh, well, no, I mean, uh, I beg to differ. I mean, I might not say it all the time, but the first book I ever wrote in this type was called In Contradiction, and I
That's
point
true.
that out explicitly.
Okay.
So to say that something is false is to say that its negation is true. And if I think that some contradictions are true, I think that some things are true and false. Now, it's a bit more complicated than that because the word false is ambiguous.
Right. As between denial and negation?
Well, no, that maybe, but that wasn't what I was thinking of.
Okay, I see.
Between truth of negation and negation of truth.
I see.
So it's not the same to say, well, consider two claims. This is not true, and the negation of this is true. There's a scope distinction here, to put it in logician's terms.
Right.
One case, the negation goes inside the scope of the T, the truth. In the other, it goes outside the scope.
Right.
Of course, classical logic identifies these two things. But once you're dealing with any logic in which some things are neither true nor false or both true or false, that equivalence has to disappear.
Right.
So
So what's the correct relationship then, in your view, between those two?
well, in my view, if it's not the case that something is true, its negation is true. If you believe in truth value gaps, it'll go the other way.
Okay.
But I mean, assuming there is a distinction to be drawn here, then when you've said that some things are true and false, what you said is that they're true and their negation is true. That leaves the question open of whether things can be true and not true, which is a different question. If they are, then the truth predicate itself, and not just the things we apply it to, behaves inconsistently.
Interesting. This is going to matter for your meta theory too, because like when you define the
Yes,
designated values in LP, for example, this is going to show up as very important all of a sudden. I see.
yes, yes, yes. No, this does affect the question of how you construct your meta theory. Okay, and look, the word meta theory is thrown around and it actually means lots of different things. It can be a theory of truth, it can be a theory of validity, it can be a theory of proof. These are not the same.
Right.
But we know look, until 1975, the orthodox theory of truth, to the extent there was one, was a tasking theory.
T schema.
Well, no, that a language cannot contain its own truth
Oh,
predicate.
right. Okay. Yeah. Yeah. Gotcha.
All right. That orthodoxy, to the extent there was one, went out the window in 1975. Saul
With
Kripke,
Kripke. Yeah. Okay.
who said that's crazy, and I'll give you a bunch of reasons why. Actually, most of these reasons were known before, but Saul put them in such a sort of cogent way that you couldn't prevaricate anymore.
Is this his sketch of a theory of truth or outline or whatever?
Outline of a theory of
Yeah,
truth.
yeah. Okay.
And since then, most of the work in theories of truth, although not all of it, has been on theories with their own truth predicate.
So what's the
And
basic move? Is it to define a class of sentences that are grounded or something and exclude the other ones?
yeah, look, so take a step back. If you've got a language with its own truth predicate, and you've got the T schema, which most people assume, Snow is white is true, if and only if Snow is white, then you can't have classical logic because you get explosion. So the cost is that you have to have a non-classical logic, and the sort of two things which are on the table are mainly a logic with truth value gaps and logic with truth value guts. So a logic where something's neither true nor false, or logic where some things are both true and false.
Right.
Okay. And both of those are articulated. And there are sort of lively debates about which way you should go on this. Now, what you're mentioning about grounding is this. Some things are going to be plain old true, plain old false. 2 + 2 is 4, end of story, right?
Right.
So there's a question of when things are going to have this non-classical status, neither or both. And the construction that Saul used was one which said, well, you start off with these very simple things like Snow is white or 2 + 2 = 4. And then you have this kind of construction which involves truth and which allows you to explain the truth of more complex sentences in terms of the simpler things. And the ones that have this sort of unknown classical value, let me put it the other way. The ones that have a classical value are the ones that are grounded in this process.
Right.
Ones that have the paradoxical value are the ones that are ungrounded. So that was the connection there. And that will work for both truth value gaps and truth value gluts. That was realized very fast after Saul's paper.
Right. Exactly.
So the debate is whether there are reasons for praying gaps and gluts. And that's something that I and people on the other side of the fence, like Hartree-Field, argue about. Of course, I think I'm right. And of course, Hartree thinks he's right.
Exactly. Is there any sense? So can we? What verifies the verification principle? The dialethism here, in the sense of one might wonder whether one kind of dialeth is paraconsistent logics at the meta level are true and aren't true or something like that. Is that going to be something which you would be open to, or your face is suggesting no? So
Well, my face is mentally suggesting that I'm not quite following this. I mean, I'm not.
so someone wondered, like, if you're asking yourself, is the correct theory of human reasoning paraconsistent, then someone might paraconsistently say yes and no.
That's a theoretically possible move. Okay. Now we're into the weeds of what a paraconsistent meta theory for a paraconsistent theory is like. We know that you can have non-classical meta theories of non-classical theories. We know that
That's kind of what made me think of it. Yeah.
I mean, that was all worked out by, Dutch logicians a long time ago. What a non-classical meta theory, what a paraconsistent meta theory of paraconsistent logic is like, is still a work in progress. We know how to do it for truth, for example. How you do it for validity is not so clear.
Right.
On some approaches, you can have an inference that's valid and invalid. On some, you can't. If you can have inferences which are valid and invalid, there's the question of what that tells you about reasoning.
Yeah.
that's an interesting question.
And the
But
relation of like trivialism, I guess, right? The idea that just
well, trivialism says everything is true, or at least
exactly.
it's a theory which can prove everything. And although some people have endorsed this, most people think that, even I think that's Looney Tune stuff.
Okay, even you. That's that's a nice way of putting it. But just real quickly, because the reason why what made me think about all this was I was thinking about your definition of designated value, or maybe that's not your definition, but the way you define the designated values in a system, like for example LP, and you say, look, okay, so we have the traditional designated value, that's truth, and then we have this other one, both true and false, and we want them both to be designated. So we want to preserve those in our inferences. Great, wonderful. And then one way you've kind of explained this sometimes, you say, look, if you have an inference that has contradictory premises, then the conclusion's true, the premises are true, the conclusion's true. Yeah, the premises are also false, but it's clearly the premises are true and the conclusion is false, right? So that's one way that you say it. And then also in the case, though, where the conclusion is contradictory and the premises are contradictory. So then I'm wondering how you pair up the truth values. So you tend to say things like, well, the premises are true and the conclusion is true, but the premises are true and the conclusion is also false. So does that not count, or how do you group set them up so that you get true and true instead of true and false in the relata here,
Yeah.
when you're saying it's valid?
Okay, look, that's an interesting question. But let's come back to
Okay,
this distinction between the ambiguity of the word false. If it just means has a true negation, then there's nothing to see here, because it just means that, okay, premises are true, the conclusion is true, and the negation of the conclusion is true as well. Okay,
right,
you can have that even in classical logic,
exactly.
and A implies A and it implies not A. That's not terribly exciting, but it's more interesting when you have true premises which give you a conclusion which is not true. Okay, now that tells you nothing about validity as such, because to get a conclusion about validity, you need a definition of validity. And standard definitions of validity, well, there are a couple of possibilities, but the one that's usually used in logic is in terms of model theory, in which you're not talking about truth, you're talking about truth in an interpretation.
Right.
And truth and interpretation are not the same thing, because an interpretation is a set theoretic construction.
Right.
So truth and interpretation is a relationship between a sentence and a set theoretic construction, whereas truth has nothing intrinsically to do with sets. So where the discussion goes at this point is you need to know not just about things being true and not true, but things being true in interpretation and not true in interpretation. And that brings us back to what I was saying just now. There are some accounts of paraconsistent meta theory, accounts of validity, where that can happen. And there are some where they can't. And what that tells you about these rival theories is something that we're still discussing.
Interesting. Yeah, I mean, okay, so many ins and outs. I mean, if there's one thing I think that anyone can take away from this is that the issues are so much more complicated than they're often made out to be. And just as a side note, as a parenthesis to all this, I would just say one of the great things about your little book, the Small Introduction to Logic, which I use in my logic classes, one of the great things about it is that it teaches logic like philosophy. And it doesn't hide behind this false sense of like rigor and these things are obvious. The rigor is there, but it's there to illustrate how like flexible these things are actually, and how many choice points there are, and how much of it is theorizing. And I can't stress enough that the average person who's thinking about these things doesn't think that logic is theorizing. They think of it as like, math, which was somehow that's how reality itself is, and there was a burning bush and it told us that yay, thus it is, but it's just not that way. It's so much more complicated, and I think
No,
it's valuable.
you're dead right. Look, our theories of logic have been evolving for at least 2,500 years, and they've been changing, and we change our minds about things. Are we at the end of the process yet? Shit, no.
Yeah, exactly.
Okay? We're still discovering lots of things. And other theories we have in the year 3000, if we manage to get there, which at the moment looks a bit unlikely, going to be the same
Yeah,
as they
well,
are now?
that's a
Of course
different
not.
story, Graham. Yeah, exactly.
But uh, when you say that ordinary people think like this, actually they don't, because there's this subject, as you know, called XFI.
Yes.
People actually go around and ask real people what they think. Okay, and it turns out that a lot of people are quite happy to say that in some circumstances a contradiction can be true or neither true nor false. So there are studies where you go around asking people, suppose it's raining heavily and then it suddenly slows down and it stops. What about the transition
Raining and
between,
not raining.
and is it raining? Is it not raining? Is it both? Is it neither? And some people will say, well, in that transition zone, it's both raining and not raining. And well, and it's neither raining nor not raining. Okay. And this is what people will say, right?
Exactly.
So the people who say, oh, Jesus is all mathematics, are people who've done Logic 100 in one of our esteemed universities.
Exactly.
And we teach logic very badly.
Exactly.
Okay.
Yes.
Often it's taught by people who are not logicians. They pull a sort of standard textbook off the shelf and they say, fill in the ones and zeros. I know it looks crazy, but allez en avant, la faire répondre, or whatever it is. You'll get used to it. So students come away with the thought that, Frege brought down the tablets of the Begriffsschrift from Mount
Exactly.
Igiena, and that settled everything,
Exactly.
and he didn't.
Exactly. There's only one person who got everything right, and that was Beethoven. He got every next note correct.
Well,
I'm
he
kidding,
did a bloody
obviously.
good job for
Yeah,
sure.
exactly. But this is important because I mean, things are messy, and we often like to point out, Aristotle had all these naive theories, and then we've corrected most of them by doing science and advancing those theories. And psychologists sometimes say, why would we expect the mind to be different? And the psychology has advanced Aristotle's theory too, but logicians should say the same thing. And we should not be doing what Kant said that it's all been perfected. We're just cleaning up the details. We're actually still doing some foundational work about what reasoning itself is and what counts as getting it right. It's not obvious, and I think that's what's important about the fight that you're engaged in. Why I like engaging with your work, because it really brings that to the front. So I just wonder do you have any opinions about why psychologically there's such an entrenched reaction to people who want to challenge the non-contradiction, and people are friendly to these paraconsistent ideas, that something irrational about it, something fundamentally psychologically abhorrent or something. So it can't just be we all read Aristotle, right? Because we didn't. So, and his arguments were bad anyway, and they would only convince someone who is already convinced, you might think. So is it just that this is natural, or have we really internalized a simple theory? Or what is your take on this? Or do you have
Yeah.
one?
No, that's a good question. I think there are probably several things going on, but one of them is the fact that Aristotle defended the law of non-contradiction in the Metaphysics, and for a long time, Aristotle was taken to be the guy. Right. So if you look at most Arabic philosophy or most medieval Latin philosophy, it's assumed that Aristotle got everything right,
Yeah,
and they
he's the
work around
master of
that.
those who know.
Yeah. So now, of course, we don't think he got a lot of things right. And in fact, if you look at the history of philosophy post the Scientific Revolution, it's us thinking Aristotle got most things wrong.
Right.
Uh, uh, So I think the answer is partly sociological. And in some sense, it's kind of interesting that I think that the principle of non-contradiction is something like the last bastion of Aristotelianism. And it's about time it fell. So that's one thing. But another thing is that people often don't think very deeply about these things. Um, and someone says, "Oh, contradictions can be true," and they think, "Oh, well, okay. How can a chair not be a chair? That's silly, right?"
Right.
And that's something that Wittgenstein called
The poor diet of examples.
exactly.
Yeah.
Yeah, we don't think about some more unusual cases,
Hmm.
and that's not uncommon in the history of science and mathematics. And a very clear example is that is the infinite. So,
Right.
there's a paradox of the infinite that's been known ever since, well, at least late Greek philosophy, that if you take the natural numbers, 0, 1, 2, 3, 4, 5, 6, and you throw away the odd ones, you're left with the even ones, 0, 2, 4, 6, 8, and there's the same number because you compare them off one for one.
Hmm.
So, but of course, there's got to be more numbers than even numbers. So this is a paradox. And so for a long time, it was thought that that just showed that the notion of infinity was incoherent.
Right.
Then along comes Cantor in the late 19th century and says, hang on, look, it's not a paradox, it's true. And in fact, it's not only true, it's the definition of infinity.
Yeah.
So, an infinite set is exactly one where you can have it and you can throw away some things and have something the same size. It's the finite ones that you can't do that. So, of course, people find this counterintuitive because they're not used to thinking about infinite things.
Right.
All right, fine. That's Wittgenstein's diet, inadequate diet of examples. And I think that often is what's going on with with dialethism is that people don't think about the sort of recondite cases like the liar paradox or paradox of motion or whatever. They just think about, plain old boring facts.
It's so
Then they
boring.
find it hard to get their head around. Okay.
Exactly. But also I would say that the liar's paradox is also often regarded as, present company excluded, trivial or not interesting, or
Yes.
something like if it is paradoxical, it's because it's weird or not usual or
Sure.
typical. And I think that's what's good about the things that we didn't start with. I didn't start with the liar's paradox for that reason, because I
Mm.
think these things. This is just a clear example that logicians like to talk about because it's very clear. But it's not like it's the only one that you can think of, or that there's something weird about this case. Like this case, the features generalizes to the other cases.
No, that's right. I mean, it often sounds like a logician's party game, right?
Yeah, exactly.
It must be said that no great logician has ever treated it like that because it tells you something, we don't know quite what, but it tells you something profound about truth.
Right,
And truth is one of our key notions in philosophy and real life. Okay.
right,
But I mean, even if you had that problem before the beginning of the 20th century, it's no longer possible to have that because paradox of this kind turned up in the foundations of mathematics itself.
right.
And so they caused one of the three crises in the history of mathematical foundations. And of course, logicians and mathematicians have been wrestling with that ever since the discovery of Russell's paradox and the cognate paradoxes.
Exactly.
So these self-referential paradoxes are actually profound.
Yeah, no, I agree with that, but I just kind of wanted to point out that they're not the only examples. And you shouldn't dismiss them as well. They are profound. I agree that they are illustrative of this thing. So that ordinary people who are kind of like, oh, I'm suspicious, because I teach this stuff, and it's easy to write the liar's paradox on the board and get people to have the intuition about it, but it's not easy to convince them that it's not a trick.
Sure.
And then when you talk about motion in these other cases, they're much more convinced by their intuitive sense of like it just doesn't look contradictory. So then you have to. That's why I want to spend a lot of time saying, well, what does that mean,
Yeah.
even? So I think that's good. Now, how far do we want to kind of take this? Because we've got these. We've been talking a lot about the law of non-contradiction, and the excluded middle has shown up here and there, and that's all great. But you've also suggested that there's this other, the fifth corner, as you put it, of four, which is mind-boggling. And I think that this is going to maybe brush up to some of the stuff we've already talked about with meta theory, So maybe that's gonna some of it we can refer back to, but the kind of ineffable nature of reality or something like that as being a kind of that the Nargajuna neither, none of the above. It's neither both, neither true nor false. So I wonder if you could just say a little bit about how these things relate um, to the things that, so the notion of the ultimate and ineffable to the notions that we've already been talking about, paraconsistency and so forth.
Okay. So, look, it's actually quite simple.
Good. Oh, that's nice.
Um, one of the things that philosophers, East and West, have always done is argue about the limits of our concepts, the limits of our language. Are there things such that they transcend our ability to think about them, talk about them? Um, and many philosophers have answered the question, yes.
Right.
So, you find this in Greek philosophy, you find this in medieval philosophy, both Arabic and Latin. You find this in Kant, you find this in Wittgenstein, you find this in Heidegger. On the other side of the world, you find this in Sankara, you find it in Dogen, you find it in Nagarjuna, you find it in Zen. And all these philosophers have answered the question, yes, there are certain aspects of reality which transcend our ability to describe, think about them. Okay, and they have a bunch of reasons for these things, which is different in nearly every case.
Right.
That's okay. Now, suppose you hold one of these views, then you think there are things which are literally ineffable. But you give reasons for why there are such things. If you give reasons why there are such things, you've got to talk about them.
Right.
So you say they're ineffable, but hey, you've just talked about them, so you seem to be involved in a contradiction. And the contradiction is not rocket science, it's bloody obvious,
It's
right?
right there. Yeah.
Now, one thing you can say is, oh, well, all these theories are wrong. That's a possible response. Of course, the people who subscribe to these theories, like Wittgenstein or Heidegger or Kant or Nagarjuna, are not going to say that.
Right.
Some of them have tried to sort of suggest ways out of it, which have been largely unsuccessful. We can talk about that if you like. The other possibility is that at the boundary between the effable and the ineffable are some things which are both. So these theories tend to produce new examples of dialetheas. And in some sense, I think these are the philosophically most profound that have appeared so far,
Right.
just because they're dealing with this fundamental question about the relationship between our language, our thought, and what the things we describe and talk about.
Exactly. So I'm most familiar with Kant out of those list of people that we were talking about, but I know some of the stuff about the other guys as well. But so I hear you saying two things, and I was trying to get them apart a little bit. But one of them is that if you invoke the ineffable, you're already in the realm of dialetheia. So you're already saying you have to say something contradictory because you're describing the indescribable in essence, basically. You're saying something about that which you can't say something about, or versa. Anyone who teaches Kant knows that you're like the noumena are like objects, but they're not objects. They cause our experience, but they're not causes. Like you can't even say anything without sounding like a fool when you're talking about Kant's theory of the noumena. So that's great. I agree with you about that you're going to end up saying contradictory things trying to describe these theories. But also there was this other thing, which is that the ineffable stuff, although you can't call it that, whatever it is, can only be described by a fifth category, which is sort of semantically, I guess, neither of the four options, some other option. And that's what I was trying to get at, because I don't understand what the other option would be if it wasn't sort of reducing to one of these other four options. Like it sort of sounds like we're saying it's both, or that it's one or the other, or that it's neither, or I don't know. So anyway, yeah, so I agree with you about the first point, and I'm trying to understand how you kind of understand this second point.
Yeah, look, So there's a question of how you handle the ineffability logically, especially when it's contradictory. Um, but the simple answer as to why people, including me, have thought you need a fifth category is quite easy.
Okay.
Namely, suppose you've got some ineffable state of affairs. Let's call it A. And now let's suppose you consider sort of things you can say by compounding statements about that, like not A or B, or A and B, or if A then B. Then if part of that's ineffable, it damn well looks as though the whole thing should be ineffable. If you can't express a part, you can't express the whole, right?
Right.
I disagree with that, but it's a natural thought. Now, if you look at the theories, the standard theories of how the categories of both true and false and neither true nor false behave, they don't work like that. You can have something which is just plain true or just plain false when one of the parts is neither true nor false or both true and false.
Well, it depends on the connecting operator.
Yes, yes, and often this value, this fifth value, is described as infectious. Its
So
value,
regardless of the operator, it's going to take over.
yes,
Uh-huh.
okay. Now
And
the
you're saying
standard,
these other values aren't like that.
correct,
I got it.
correct. So I mean, there's lots to disagree about there, but if you can see why you might be motivated to think
Yeah.
there's a fifth value. There's got to be an infectious value, and so we understand how the fifth value works quite well, and this kind of recherche metaphysical reason is not the only application it's got. I mean, for example, you might think that computer programs that crash can be given the fifth value, or at least the output is given the fifth value. It's just all hell's broken loose, right? So sometimes the fifth value is interpreted as crashing.
Is the fifth value going to be like when the equations of the standard model go to infinity before they're renormalized or something? Because if this is the crash, is this analogous to the crashing? Because a lot of physicists would
Yeah.
interpret that as like a crash in a sense.
Look, I've never heard anyone make that suggestion before, but it's an interesting suggestion.
Interesting. Okay.
It's it's when you've got a real snafu.
Yeah.
Okay.
Exactly.
So, we know the logical technology. That's relatively uncontentious. With any logical technology, the question is, how do you apply it in interesting cases?
Right.
That's where the rubber hits the road always.
Exactly.
And if you're minded to think that you can show or argue that there are things which one can't talk about, your rubber is certainly hitting the road big time.
Yeah, exactly. It would pay. Yeah, it's interesting. Okay. I just this is a total non-tangent, non sequitur, but so maybe you don't have nothing to say, but I wonder now, do you have any thoughts about like non-classical logics that involve imperatives or questions? Like, are you kind of a classicist in that sense that you think everything's got to be some kind of semantic value, or do you think you could have like a logic of go to the store, or because I've always been a fan of that. I look in the refrigerator, there's no beer in there. I think if no beer, go to the store. Then I conclude go to the store.
Yeah.
So I this maybe is not relevant, but I just thought of it, so I wonder what you think.
Look, I do think we draw inferences that involve commands. So suppose you tell me go to the shop and get some milk and some bread, and I come back with some bread. Then it's perfectly fine for the person to say, yeah, look, I told you to get the bread. Where's the milk I told you to get?
Right.
So it looks as though the person is inferring that when he said or she said, go get bread and milk, he commanded to go get bread and commanded to go get milk. Okay. And that seems a kind of natural inference to draw.
Right.
Obviously, if you want to give an account of what's a valid inference in this kind, the guy didn't imply go and get some chilies. Okay. So if you want to give an account of what's a good inference, what's a bad inference in this case, you can't do it in terms of truth. It's got to be something to do with the satisfaction of the command. So, when I brought the bread home, I satisfied the command, at least part of it.
Right.
So you've got to tell an account of validity in terms of
Compliance or obeyance or something.
compliance.
Yeah.
Yeah. Now, where it gets really messy and interesting is that we can combine statements with commands.
Right.
If it's raining, take your umbrella.
Exactly.
So we seem to mix statements with commands. Now, how do you talk about the validity of that kind of inference when you've got different kinds? You've got truth on one hand and sort of realize a satisfaction, whatever you want to call it, on the other, and you've got to put those together. Look, I've never thought much about these issues. A lot of people have thought a lot more than I have, but that's a really interesting question.
Yeah, it is an interesting question. Yeah, exactly. And then also because you kind of maybe saw where I was pushing towards was that if you, I made, because I wrote my dissertation on metaethics, and I was interested in this kind of logic of imperative stuff. And I kind of made an offhand comment where I was like, well, you can obey or not obey. So that's a binary thing, like true or false. So you can just like truth value it out from there basically and do your truth tables or your compliance tables or whatever you want. But now if you're a pair consistent, so if you think truth can be dialethic, then you have to wonder whether these other things can be, in some sense, analogous dialethic, complied and not complied, or whether it's only truth that admits of this Janus face, if you will. So I wonder if you have any kind of thoughts about that, whether it's only truth that admits of this.
No, I think it can. Look, let me give you an example. It's a sort of toy example, but it'll do.
Okay.
Suppose you say to me, Graham, go and find me a man. I say, okay. And you say to me, oh, and while you're at it, find me something that isn't a man. I say, okay. Now, my next door neighbor is Jesus, who is both a man and not a man. Maybe not the Jesus, okay,
Oh, right. The other Jesus.
but some person who's a man and not a man. And I say, look, the easiest thing for me to do is to get Jesus in here. So I get Jesus in here. I've found you a man and not a man, right?
Did you comply and you're not comply?
And I complied with both your commands in one hit.
Exactly. Exactly. Okay. Yes. Very good. This is fun stuff. Okay. So I'm ever more increasingly aware that time is progressing. And I know I've been asking you all sorts of questions, but I do wonder sort of at the end, I like to ask whether there was anything that hasn't come up that you wanted to have come up or that you would like to speak about, and the answer can be no, but maybe there was something you were expecting or that you wanted to bring up.
No, I wasn't expecting anything. I'm always happy to go where other people want to take the discussion.
Very
I don't
cool.
always have anything interesting to say about it. I mean, I know that your program is about consciousness, and I don't really have anything much interesting to say about that.
That's interesting. Well, it's about consciousness in the sense of that invokes the mind. And then we can talk about everything in the mind. But you do, I mean, so just since you did say the consciousness word, I will say that some of your stuff relates to it because you talk about personal identity. And I think of that as being related to consciousness in some sense, because probably consciousness is at least a candidate for something that seems like important in this area. And you think that maybe there's no, that one of the Buddhist truths that have been kind of verified by science, or at least, held up by it, is this idea that the self is not an existing thing that confirms your identity through time. So maybe in that sense, you do have something to say about consciousness?
Well, personal identity is an interesting question, and of course, a contentious one, both in philosophy, East and West. But presumably, identity survives change. You can be the same person today as tomorrow. Um, and if there's a problem about change, there's a problem about change that affects people. In fact, oddly enough, this came up yesterday. I was chatting to someone who came to talk to me, um, and she'd been reading some dialethism and stuff. And we were talking about, what sorts of things might be contradictory. And she asked me, what about contradictions in the world? And, just a bit like you do. And
Yeah.
we start to talk about change of motion, change. Well, okay, so motion, but really it affects any kind of change, really, because
Well, the Greeks
okay,
knew that local motion was just one kind of motion, like corruption, generation.
yeah,
Yeah.
okay. So take the point that it's just a special case, and the kinds of worries that about motion are going to affect all accounts of change. That's not entirely obvious because motion does look like a special case in that Zeno arrow, but it isn't. So she sort of looked at me and said, "Oh yeah, but look, I'm interested in change that affects me." Okay. She said, I'm changing all the time. So does that mean I'm in a contradictory state? And this had never struck me before.
Interesting.
I said, oh, well, actually, yes.
Yeah.
So next time she's wondering what to do with her life, I don't know, she might find herself in this contradictory state. And, we find ourselves with beliefs that are inconsistent, with desires that are inconsistent. We want to do something and we want not to do it.
Right.
We're torn. That's not a contradictory state.
Right.
It's not a contradictory state that I want to bring it about that P and I want to bring it about that not P. The contradictory state is that I do and do not want to bring it about that P. Okay. And if I'm changing from one state to the other, what's the transition state? Well, if you believe this stuff about change, then it's a contradictory state.
Yeah. That's so interesting. I mean, in a way, you can see it as tying up to like things that Sartre said about personal identity and choice. And if you think that nothingness is contradictory object, and if nothingness lies coiled in the center of being like a worm, then yeah, maybe these
Yeah.
ideas
Well,
fit together.
no, I mean,
Interesting.
Sartre comes bloody close to dialethism. Okay. Um, he says that,
I am what I am not, and I am not what I am.
yeah, it's not quite that, but it's something like, um, I am what I will be in the mode of not being. I'm now what I will be in the mode of not being.
Ah, yes.
That,
It sounds like the Hegel motion idea applied to himself in a way.
you can read it that way. And of course,
And maybe that's what your student was intuiting in a sense. Like there's this kind of inherent contradiction as you as you try to change yourself towards some.
yeah, maybe she was tapping into that thought. I mean, she'd never studied any philosophy. She was a mathematician,
Interesting.
but maybe that's the thought that she was tapping into. That's true.
Yeah, interesting. Okay. Wow. Yeah. See, so I think that this old, I don't know who was it. Was it Davidson or Quine? One of these old guys who said that you have to always theorize people as being rational. They just didn't know any interesting people. So it's sort of give people their due. Sometimes they believe contradictory things and they're rational. you know.
Oh, I think that's true. Look, I mean, often people say that scientific theory is never inconsistent, and that's just plain false.
Right.
So, I mean, one of the paradigm examples is early Newtonian dynamics, because that was based on the infinitesimal calculus.
Right.
Infinitesimals were assumed to be both zero and non-zero. Berkeley ridiculed this. He called them the ghost of departed quantities.
Yeah, he should have. But that I don't know the history of this. People will debate you on this, but I sort of thought that there was this idea that they had Newton. I thought had three different versions of this. It's sort of more increasingly precise or something, and that they thought of them as kind of a fiction. Leibniz maybe thought of infinitesimals as a useful fiction or something like that. So I don't know.
Well,
Yeah, yeah.
okay. I'm not enough of a Newtonian or a Leibnizian scholar to go through their texts of what they actually said, but the physicists who applied their theories for the next 250 years, 200 years, in their mathematics, they took infinitesimals to be zero and non-zero.
Right. And Newton kind of uses them as both. He sometimes teaches as zero and sometimes treats them as not zero.
Exactly, exactly. So you have to assume that they're both,
Yeah.
maybe in different parts of the computation. So the theory was based on inconsistent. The physical theory was based on inconsistent mathematical theory, and physicists did not worry about this,
Yeah, I guess I don't know if it was
and
the
they were
physicists or
rational,
the
presumably.
engineers. It was one of those guys. I think the engineers didn't worry about it. I think the physicists were kind of worried about it.
Look, it really didn't worry Newton. It didn't worry the physicists who came after him, like Laplace and the Bernoullis and so on. They were quite happy to use this mathematics,
Yeah.
and they were kind of you'd be to say that they were being irrational would be a bit
Yeah, it's mean. I know it's not
disingenuous.
true and it's mean. Yes, exactly.
I mean, what they were doing provided the most profound theory of motion that we had up to that point in history, with predictions which were pretty bloody good.
Exactly. I agree. Okay. Yeah, no, I'm just thinking five things at once here. Okay, so there's a lot of follow-ups. I'm, find this stuff so fascinating and so interesting. And I just think that it's very important to keep bringing us back down to how practically important this stuff is in various areas we find. So not just the ivory tower or the logician's dusty notebook. These issues impact how we do science, how we should think about psychology, and these more practical issues as well. So I think that's sometimes lost in these debates. I'm glad that we highlighted it. And generally speaking, Graham, this has been so much fun. I appreciate your time and your patience, and I'm glad you're out there fighting the good fight, because I know you put up with a lot of characterization of your views, and you've been doing it for years out there fighting the good fight. So I'm very happy that you're doing that. Thank you for all your work.
Well, you can put views out there. You have no control over what people make of them.
Yeah,
Okay. Uh, One hopes that people will make interesting use of them.
exactly. But you do more than that, though. You're defending it, and not only that, but you're coming on here and talking to people like me, who are public facing in some sense of that word, where you're not just talking to your fellow academics, but you're actually saying these are important things for us to take into consideration, people who are interested in these questions about reasoning and how to do it correctly, or how we ought to.
Yeah.
And I think
Well,
that's good. That not a lot of people do that.
I think that professional philosophers have a kind of duty to get out there and engage with the public. Um, Not necessarily about the kind of paradoxes and things, but about all the important things that affect people in their daily lives, politics, morality,
Right.
so on. Because philosophers have the ability to think about these things carefully and not come up with some dramatic and dogmatic or half thought through position. I mean, the public intellectual is a feature of continental Europe, not the Anglosphere. It's hard to think of a public intellectual in the Anglosphere. I mean, Chomsky is maybe a good example,
Yeah.
but philosophers by and large are not. And I do think we have a public
What not,
duty.
not yeah.
You
No.
know?
What about Peter Singer? No.
Oh yeah, and Peter.
Okay. Yeah, but we don't have enough. I agree with you. We need more. We need more representation.
Yeah.
Just since you mentioned that, I wonder: are there dialetha in the ethical realm, on your view, like veganism, stuff like that, or is this not something where our ethical truths going to resist dialethism?
Look, it's going to be contentious, and it really does depend on your view of ethics, I think. Look, let me give you a very simple example.
Okay.
Some people think that what is morally good is what God commands.
Mhm.
Uh, I don't think that's true, but some people do.
Yeah.
Um, Now, suppose God has a bit of a sense of humor and says, "Hey, Graham, you're obliged to do this." Oh, and but you're not obliged to do it. Yeah, no, maybe I've been a bad boy and he wants to put me in a,
He
in a
wants to mess
bind.
with you. Yeah, exactly.
Yeah, he's going to punish me whatever I do, right?
Exactly.
So this, in this sort of scenario, yeah, I mean that's a dilethia, a moral dilethia. Now, I mean, I'm not suggesting one takes these ideas seriously because I
Yeah.
don't think that one would think that the divine commander theory of morality is correct, or if one does, I don't think one would think that God could screw around like that.
Yeah.
But it just shows that what you might say might depend on exactly what you think the ground of morality is,
Right. But
and
also
complete
whether you,
everywhere in morality.
I mean, if you're a utilitarian and you think that you can do some actual math here, and you think there's a paraconsistent like theory in the background of the math, then it does sort of, and you might think you need this to psychologically model states like bittersweet emotions, like psychologists are interested in the phenomena where you could have won $100 but you won $5. So
Hmm.
people feel like they're happy about it, but they're also like they think it sucks kind of, so they're like this is terrible but it's also good, like so that bittersweet phenomenon. So maybe you would need a paraconsistent model to make sense of those kinds of things. They're good and they're not good, or so I don't know. It
Maybe
is it is
but that's
interesting.
that's to do with psychological states rather than morality. But
Well, no,
there
that's why I said if you're utilitarian.
oh, I see. Got it.
Yeah. So I was just, yeah, just thinking out loud. I wasn't really saying you should adopt that view, but yeah,
No,
interesting.
no.
And especially if you're a Kantian and you think that rationality is somehow important for like morality, and you're also a paraconsistent dialethous type, then I think you're going to be having some interesting questions about categorical imperatives and things. So I wonder. I don't know if any work on this. I don't know if anyone I could go and read that's written about like paraconsistent categorical imperatives. Is there anything about that?
No, I mean I've written stuff about contradictions in law,
Yeah,
so
that
we
those that I
in
know. Yeah,
this domain. I've never sort of ventured into dialectics in moral philosophy just because moral philosophy is so murky.
yeah,
But I mean, dialectism just says that some contradictions are true. Doesn't tell you which one.
right.
Which ones? Well, the ones that our best theory tells us are true. What else? But then we've got to decide what those are, and that means we've got to look at different theories of different things and
Hmm.
figure out which is the best. So dialectism as such doesn't tell you which the true contradictions are, but what it will do is open up a whole new vista of possibilities so that before in any theoretical inquiry there can be different theories and all the consistent ones, if we're investigating something, all the consistent ones are still there. It's just that now they're going to be some inconsistent ones too. So you've got a larger bunch of theories on the table. You've still got to choose. And maybe the best theory is going to be one that's consistent. Maybe it might be one of the inconsistent ones because
Right.
that's on the table now. So the effect of dialectics on rationality is not to, doesn't sort of change anything fundamental. You're still constructing theories and choosing the best. That's what rationality is about. All this theoretical rationality, not practical rationality. Um, but it just shows that your choice might have been wider than you thought.
Right, exactly. It just widens up the scope of possibilities. But sort of, so with respect to consciousness, this is one area where I kind of wanted to wrap things up here because we mentioned it briefly already, but consciousness is one area where people have flat out said it resists contradiction. I'm thinking of people like David Chalmers and Kelvin McQueen, in particular, when they wrote their paper about quantum theories of consciousness. And you don't need to know about that stuff. But basically, their idea is that I think you could kind of put it this way, that phenomenologically, nothing presents itself outright as a contradiction. And in the so like the way you described Sylvian's box, that story which I mentioned a while back, which is your short story, and a paper too that draws some lessons from it, but the short story in particular has this box where the person looks inside. I forget who it was, some character, Sylvian, I don't know who it was. It doesn't matter. They look in the box and there's a contradictory object in the box, literally something that's like a square and not a square, or a circle and a square. I don't know, some contradictory thing in the box. And they see it. And you describe them as being very disoriented when they see it, like, because it's like that and it isn't. And that would be very confusing because our experience isn't like that. And whatever else you think about the Zeno case and the objects moving, it doesn't look straight off the bat like it's there and not there. It looks like it's continuously changing location, or at least that's how I would describe it. So I guess you could sum up my little thing here by saying phenomenologically, the world presents itself classically in a sense, as obeying the law of non-contradiction. In experience, that's there. And one thing you might draw from that is, well, because consciousness itself can't be in contradictory states, that you can't be in a state of seeing green and red or square and circle at the same time. And yet you describe someone as being in those visual states. So A, I want to ask you what you think about this, but B, also, don't you think that it is sort of the typical case that phenomenologically things do present themselves in a way that would lead you to accept something like the law of non-contradiction with our diet of regular examples before you go to infinity and all that stuff?
Look, I find it kind of plausible that our normal experiences, our phenomenological experiences, appear to be consistent.
Okay.
That does take us back to the question of what a contradiction appears like.
Yeah.
And, if
But
you were
but
to,
but you didn't describe Sylvan's box as having like an ordinary thing that was contradictory. It like had this flat out, like it looked that way, which is very
oh, no,
different
no.
from
I
everything
mean,
else.
sure, look, this was a work of fiction.
No, I know that, but I'm just saying it's striking that it's very different in this way.
Yeah, actually, I do think our phenomenology can be inconsistent sometimes. Um, you can see something that's both red and green at the same time.
Checkers.
No, I don't know if you ever went to an old-fashioned three-dimensional film, and they would give you a pair of glasses with green filter in one eye and red filter in the other. And if you get a pair of those glasses and you stare at a white wall, then it's very strange for a moment. Then it sort of all appears a kind of muddy brown. But just for a sort of half a second or so, it actually appears both red and green.
Interesting.
At least that's my experience. There are psychological investigations on this, and it may be relative to a person.
But do you think but perception is theory laden?
Sure,
So do you think that your acceptance of a dialectic theory influences what you might have seen there? Whereas
possibly,
someone who is a classical theorist wouldn't see the red and green at the same time?
possibly.
Okay.
Uh, but I mean, there are other interesting examples because our sensory modalities talk to each other. So, for example, suppose I'm walking down the road and I look and I see a motorbike passing me and I hear a motorbike. So my phenomenology is of a single object. Okay. So it's some kind of multisensory integration
Right.
which goes on somewhere in the brain. Now, it's quite possible for your senses to tell you different things. So, for example, suppose, I'm looking at something and there's nothing there. And then with my sense of touch, I feel there's something there. So what happens to the multisensory integration of those two senses? I don't know, never tried it. But I suspect that it would be very disorienting. And the natural explanation of this is that there's something there and there's nothing there. I know. Let's apply for a large research grant to
Yeah,
invest.
exactly. That's a really good, exactly. That's a cool X-Fi experiment you just came up with right there. Exactly. Okay, yeah, because this really gets at that central, that question of what would it look like to see something contradictory, and would phenomenologically would we resist it in a sense? Because one way you might interpret the Count Chalmers point is that even if you were looking at a square circle, it wouldn't really appear that way because consciousness can't go into those states at once. But what you're suggesting is that maybe it can, and maybe empirically we could show that it does. So I think there's a very interesting question here um, about whether you can see something contradictorily. Yeah, it's very interesting. Yeah, there's so much here, and this is what I wish people would get past the like get. I wish people would get past the prove to me dialethism isn't silly and go on to the let's take it serious and draw out the implications because it has a lot of interesting stuff to say. Even if you disagree with like some parts of it, there's so many places to explore that are just waiting, I feel like, for people to go there. So
Yeah.
yeah.
Look, I mean, it's worth remembering that so much orthodoxy nowadays was proposed by people, and the Orthodox reacted to them as your suggestion is silly.
Exactly.
So yeah, a measure of humility is important, I think.
It's-
Which is not to say, dialethism could disappear and be found to be thought completely untenable in 50 years. Who knows? But it's just worth remembering that lots of things which were deemed silly are now orthodox.
Exactly. Yeah. And on that note, let's go ahead and wrap things up here. Thanks again for coming and speaking with me. We haven't even touched the surface. There's still many, many things I would like to ask you about. So someday I'll have to ask you back for more torturing. But until then, just hang around for 1 second. I'll say goodbye off the air. But thanks for all of your patience.
My pleasure. And it's been my pleasure too.
Thank you. I appreciate that. All right. Buttons are being clicked and we're